It's George Tyndall, and I'm back again here. And I'm going to go discuss a few things, okay? And I know that there's going to be some people out there that are going to be upset and disagree because of where I am going, what area I am searching in. Okay, and the reason why it doesn't make sense is because it isn't what you're expecting to see. If a meteor comes in under normal conditions, then the meteorite you find on the ground is what you're going to expect to see. If the conditions are abnormal, there's a good possibility that you can't use the same criteria that you use to identify a meteorite on the ground for one that's had been affected differently. Okay, now, I asked a question, okay? Has anyone ever gone back and checked what we consider to be correct about meteorites? Okay, now the answer I got is scientists have reconsidered and reevaluated their understanding of meteorites. While some matters have been resolved, other matters continue to be revisited and resolved. And this is why I'm going in the direction that I'm going in, because not everything has been resolved. They're always finding out more things. Now, the Earth has to have mass for the core to circulate and the magnetic field to work. Less mass will weaken the magnetic field and slow the Earth's core. Liquids, gas, and solids have mass. Volcanic eruptions eject a lot of mass from the Earth. Burning oil rids Earth of mass. Okay, there's a lot of oil burning that's been going on. Oil's converted to gas, it's been burned. Even though it's a liquid, it has mass. Okay, the Earth loses mass. Impacts from comets, asteroids, and meteor showers add mass to Earth. Now, people just seem to want to believe that massive meteor showers can't impact the Earth. Well, I think people need to go back and investigate it. From what I'm finding out, it doesn't hold water what they say about it. Why is the magnetic field weaker now and the Earth's core slowing? It's because the Earth is losing too much mass. It's not just from volcanic eruptions, which are natural, various other things. All the burning of the rocket fuel and the oil and everything. The Earth is losing mass. And we are ejecting more and more and more and more mass from the Earth, and it's not being replaced with anything. But like I said, people have to go back and they have to look at this stuff and they have to research and they have to factor everything in. If you don't factor everything in, you get what you get. Now, do we know 100% for sure rocks from space don't hit the Earth? That's a question I asked the computer, the internet. No, we do not know 100% for sure that rocks don't hit the ground from space. Okay, now I'm going to explain something here. And like I said, I know people are upset with me or whatever. I'm just trying to make people aware that somewhere along the line, someone messed up. Because they didn't go back and they didn't research After so much of a period of time, everybody just keeps going by the same criteria year after year after year after year after year, and they can't seem to find meteorites in other areas. And this may be why people can't find meteorites in other areas, because people aren't reevaluating things like they should. Okay, to make it through the mesosphere, a space rock would need to be composed of dense, heat-resistant materials like iron, nickel. Okay, iron, nickel is what's in a meteor. Iron nickel alloys with a large solid core, potentially with a outer layer strong enough to withstand the intense heat and friction during entry. Now, if you find a rock like this, okay, this has a solid core. Okay, this has an outer shell on it. The outer shell is high heat resistance. That's why only so much of it broke off. Now, that's just one rock. I'm finding a lot of ones like that. It just isn't one that I'm finding, which leads me to question, is somebody messed up? But like I said, it is what it is. And because I'm not an expert and I don't have a degree, people don't want to listen. And that's fine. They don't have to listen. Now, what scientists say is actively searching for whole space rocks is largely impractical. They say it's impractical. Okay, so it's impractical, so we don't do it. But does it make sense to think that it's impractical if it can happen? Meteorites with a fully intact fusion crust are rare, but it can happen. Now, this is the point that I've tried to get across to people, okay? And I believe that a lot of this has happened, and it probably has happened over a period of time. Okay, but we didn't have the science that we have now years ago, and people didn't know what to look for and everything. Now, the one thing that I said about ones coming and hitting the ground and being intact with fusion crust, they say that is rare, but they also say it can happen. Now, whether people want to believe it or not, that is a meteorite with complete fusion crust intact. I know people don't want to believe it, but this is. I can tell by looking at it, okay, by what the experts say fusion crust is supposed to look like. Now, if somebody can't look at that and tell, I don't know what to tell them, and I don't know what to say. But I'm just trying to make people aware of, and if you research what I'm saying, and you sit and you listen to it, then you can begin to understand. And personally, like I said, it needs to be investigated. But getting someone to listen is a total different story. It's hard to get somebody to listen when a person is convinced that it just can't happen. It just can't happen. It's rare. It's unlikely. When you start putting words and stuff like that in your findings and everything, that doesn't necessarily mean that it can't happen. And if it was investigated, I think they would probably get a lot further in science. But no one wants to touch it. It has to do with the money thing. It's a money thing. But the findings that I keep putting out there, I'm going to continue to put them out there until someone takes a look at this, what I'm saying. Because should I be correct, it would change everything. It would change a lot of things. But it's all on whether somebody wants to take a chance or not. If you'd rather progress science by 20 or 50 years within a year's period, because that's what would it do if I am correct. And I'm almost 100%, I'm sure that I'm correct. But like I said, it is what it is. And we'll leave it at that.